This is the Calculus Pre-Lecture Series. I'm Caitlin Murphy, and this podcast is on Taylor series. If we have a power series of the form sum from n equals 0 to infinity, c sub n, where c sub n are some coefficients, on x minus x naught to the n, and this power series is equal to an infinitely differentiable function, then the coefficients have to have the form c sub n equals f, the nth derivative of f evaluated at x naught over n factorial. Let's write that out really quick. This top here, this is the nth derivative of f evaluated at x naught divided by n factorial, and remember that's n times n minus 1 times n minus 2 all the way down until we multiply by 3 times 2 times 1. So in general, the power series that we're going to be studying here we call Taylor series, and their general form looks like sum from n equals 0 to infinity. C sub n has to be this specific form. So you have the nth derivative of f evaluated at x naught all over n factorial on x minus x naught to the n. This will be our form for Taylor series. So let's get a little bit of practice so we can see how we form these expansions. So we're going to find the Taylor expansion of the function e to the x about 0. So we are looking for a series with this pattern. So on the series from n equals 0 to infinity, the nth derivative of e to the x we're going to evaluate at 0. So this 0 is x naught over n factorial on x minus 0 to the n. So we really just need to solve for these coefficients. In order to do that, we need to think about the pattern that comes when we take derivatives of e to the x. So what would be the nth derivative of e to the x? In our case, the nth derivative of e to the x, you might write it like this, is just e to the x, because we know that the derivative of e to the x is e to the x. So the nth derivative evaluated at 0 is just e to the 0, which is defined to be 1. So we can go ahead and write out our Taylor expansion from here. We have the sum from n equals 0 to infinity. Our nth derivative evaluated at x naught, which was 0, is just 1. So we have 1 over n factorial times x minus 0 to the n, which we can just write as x to the n. And just to make it look a little bit nicer, we might write it as the sum from n equals 0 to infinity, x to the n over n factorial. And that is the Taylor expansion of e to the x about 0.